This is our video for Unit 5, Day 4. So far this week we've learned 3 different ways for solving a system of linear equations. So what we're going to do today is review each of those 3 ways and then move forward into solving a system where we have one linear and one quadratic equation. So it's going to be one step harder, but we're still going to follow the same process. We still have all 3 different ways available. So the first way we did, which we actually started way back in Unit 2, is solve by graphing. So keys to remember here was we always want to start it with slope-intercept form. That makes it easy to graph. Right, we're solving by graphing, so we do have to graph both lines and then find the intersections. Alright, we get into quadratics, there's going to be more than one, so say intersections, plural. Quadratics and linear, we could have as many as 2. So here'd be an example. Here I have y equals negative 2x minus 2, 2 over 3x minus 2, and then y equals negative 8 over 3x plus 4. So the way we graph these lines, remember, is we start with the y-intercept, plot that on the y-axis, and then we count out the slope. So I plot negative 2 on the y-axis. Now I'm going to count from that negative 2. I'm going to count down 2 and right 3. Down 2 and right 3. And around a room, we can go the other way, up 2 and left 3. And then we've got our line. Same idea with the second line. We have our y-intercept we plot first at positive 4 on the y-axis. Slope negative 8 over 3, which means we count down 8. And then over 3. That's the only point that's actually going to fit on here. We can graph our line. I can see that the intersection, which is the answer here, is that point, which is 3, negative 4. Remember that we always do write our answers to systems of equations as ordered pairs. Alright, so one thing as we review each of these different ways, we're going to talk about when each one's going to be easier. So when it'll be easiest to graph. So easiest to graph and solve versus using elimination or substitution is if both equations that make up the system start in slope-intercept form. Right, so that would be, if you saw one just like this here, you can still solve it any of the 3 ways we learned, but it'd be the easiest to do this by graphing. They're already in slope-intercept form, very easy to graph. If we do this algebraically, we'd have to work with those fractions. So this one would be easier to do by graphing, already in slope-intercept form. Second way we learned was to solve by substitution. Alright, so remember the steps, it was the same steps repeated. So we solve for variable, substitute that expression into the other equation, solve, we get an actual value for one variable, and then substitute that value in to find the missing value. So solve, substitute, solve, substitute. Alright, so remember that solving for variable means we get the variable by itself on one side of the equation. And this is easier with the graph because we're actually pointing at a point. Remember, we're doing this algebraically. We have to go through and find both x and y and write our answer as an ordered pair. So here's our example here. Negative 3x minus 3y equals 3, and 5x plus y equals negative 17. The way to make this the least amount of work is to find the easiest variable to solve for. So if I'm looking for the easiest variable to solve for, I look for one that maybe doesn't have a coefficient or is already pretty close to being by itself. So here I'd say this is probably the easiest to solve for. So what I would have to do to solve for that, the only thing I have to do is subtract 5x. Remember that 5x is not a like term with negative 17, so we don't combine them on the other side. Right, my next step is going to be to substitute. So I take this expression I came up with for y, and it's actually going to go into the other equation in place of y. So when I do that, it's going to be negative 3x minus 3 times this exact expression, negative 17 minus 5x equals 3. And now we're going to solve and actually get a value for x. Since the only variable in here is x, this is now a linear equation. We're going to distribute here, positive 51, positive 15x, 3. Combine like terms on this side, 12x plus 51 is 3, subtract 51, negative 48 is 12x, and divide by 12, we have x is negative 4. Alright, so that gives me x. Remember, I still have to find y, so we look for which equation might be the easiest to substitute into. You'll get the same answer either way, but we want to try and make the least amount of work possible. So let's try the bottom equation. 5x, that's negative 4, plus y equals negative 17. So negative 20 plus y equals negative 17. Add 20, we're going to get y is 3. And remember that we write our final answer as an ordered pair. So it'd be negative 4, comma 3. So again, we talk about when will this particular way be easier. This will be the easiest way using substitution if one variable in one equation is already solved for. In either or sometimes both. So if you get to a problem on your test or on a worksheet, and you see that you have one variable already solved for, it'll be easiest to use substitution there. It'll be the quickest method to use substitution there. If you got one variable already solved for, it's like the first step is already done for you. So then the last way we learned was to solve by elimination. So a couple things to remember about elimination. We only use two operations when we do this, multiplying and adding. And the reason for that is it's easier to use multiplication and addition versus also bringing in division and subtraction. So thinking about multiplying by negatives and adding is easier than thinking about subtracting. We don't make those little errors with the negative signs as much. So remember, the goal here is to eliminate one variable. Eliminate one variable by getting the opposite number in each equation. So if I have positive 3x in one equation, I want negative 3x in the other. If I have positive 8y in one equation, I would need negative 8y in the other. And the way we do that is if they're both positive, you can multiply a negative to make it cancel out. If it's negative, you can multiply by positive, make it cancel out, whatever you have to do. So we're going to use this example here. So we have 3x plus 2y is 4, 8x minus 3y is negative 6. One thing we like to look for when we do these is signs that are already set up to cancel out. So positive and negative, then we don't have to multiply negatives or worry about canceling out. We just have to make sure they get up to the same number. So when they're already set up like that, we'll work with these variables. So I'm going to create the opposite number of y's in each equation. So I'm going to multiply that top equation by 3, so I'll have a positive 6y, and multiply the bottom equation by 2, so I'll have negative 6y. So we have 9x plus 6y is 12, and here we have 16x minus 6y is negative 12. The next thing we're going to do is add these two equations together. So these cancel out. I have 25x equals, and these actually cancel out on this one, 0. So dividing by 25, I get x is 0. And I can plug this 0 into either equation to get my answer for y, same as when we did substitution. So plugging the top equation might be easier. 3 times 0 plus 2y equals 4. So that cancels out since it's 3 times 0 is 0. So 2y equals 4 and y equals 2. So again, my answer I'll write as ordered pair 0, 2. So that's just review of what we did, all the different methods for solving linear systems of equations. So for the next video, for the second part for this day, you need to watch the part of how we actually are going to go through and solve systems with one linear and one quadratic equation. If you are looking for any other resource or something else to help you with this, different videos online, you can search for systems of linear equations to help you with this video.